Welcome back students to my YouTube channel. Now in this video we are going to solve some more questions from National Level Mathematics Olympiad 2019 paper for class 10th. So let us start. In question number 11 we can see we are given if the roots of the equation a minus b x square plus b minus c x plus c minus a is equal to 0 are equal, then option A is 2a equal to b plus c, option B a equal to b plus c, option C b equal to a plus c, and option D 2b equal to a plus c. So in order to solve this question, first of all, we check the sum of the coefficients of x square x and this constant term. So we add all these coefficients. So a minus b, x square coefficient a minus b plus b minus c plus c minus a. So a cancels out, b cancels out, and c cancels out. So we can see the sum of the coefficients is 0. So we can say that x equal to 1 is one of the roots of this equation. X equal to 1 is one of the roots of this equation. Now the roots of the equation are equal. So another root, let us say this is alpha, then beta will also be equal to 1 because the roots are equal. So we have the two roots of this equation, 1 and 1. Now we know that product of the roots alpha beta, that is equal to c upon a. Now here in place of c we have c minus a, and upon a is the coefficient of x square, that is a minus b. Now alpha beta will be 1 into 1, that is 1. So 1 equal to c minus a upon a minus b. So we can simplify this. It becomes a minus b equal to c minus a, or take a to this side, a plus a equal to, and b to right hand side, b plus c. So 2a equal to b plus c. So this is the option A. So our answer is option A. So this solves this question. Now look at the question number 12. If the sum of first two n terms of AP 2, 5, 8 and so on is equal to sum of first n terms of AP 57, 59, 61 and so on, then n is equal to, we have again four options. Option A 10, option B 12, option C 11 and option D 13. Now sum of first two n terms. So S2n, that will be, apply the formula for sum of first n terms. In place of n we will take 2n. So it becomes 2n by 2, 2a. Here a is 2. So 2 into 2 will be 4 plus n minus 1, that is 2n minus 1. D, here common difference is 5 minus 2, 3. So it becomes n 4 plus 6n minus 3. That is n 6n 4 minus 3 plus 1 हो जाएगा. Now again the first of n terms Sn in another case will be n by 2, 2a. Our a is 57, so it becomes 114 plus n minus 1, and d is 59 minus 57, that is 2. So take this 2 inside, it becomes n divided by 2, 57 plus n minus 1. So it becomes n, 57 minus 1 is 56 plus में n. So equate these two, S2n is equal to Sn. So equating these two, n 6n plus 1 is equal to n 56 plus n. So this cancels out. So it becomes 6n minus n equal to 56 minus 1. That is 5n equal to 55. So n becomes 55 by 5, that is 11. So answer for this is option C, that is 11. So this solves question number 12. Now look at question number 13. A quadratic polynomial when divided by x plus 2 leaves a remainder of 1, and when divided by x minus 1 leaves a remainder of 4. What will be the remainder if it is divided by x plus 2, x minus 1? So इसमें we will use the remainder theorem. We have four options. Option A 1, option B 4, option C x minus 3 and option D x plus 4. Now let the polynomial, required polynomial, where quadratic polynomial, be P. Now it leaves a remainder of 1 when divided by 2. So P of minus 2 will be equal to 1, and it when divided by x minus 1 it leaves a remainder of 4. So P of 1 will be 4. Now we have to find that what will be the remainder if it is divided by x plus 2 x minus 1. So let the remainder be r. So r will be of the form ax plus b. Why ax plus b? Because if the quadratic polynomial is divided by these two factors, that is a quadratic polynomial, then the degree of the remainder is less than or equal to 1. So it becomes ax plus b. Its degree cannot be greater than 1, so it has to be ax plus b, some linear polynomial. Now we write p as p equal to x plus 2 x minus 1 into quotient plus में remainder, that is ax plus b. Now we have p of minus 2 is equal to 1. We can write it here as p of x. P of minus 2 is 1, so put x equal to minus 2. So it becomes 1 equal to, this becomes 0, this part, and ax plus b will becomes x equal to minus 2. So it becomes minus 2a plus b. So we have one equation, minus 2a plus b is equal to 1. Now you put p equal to 1. So it becomes 4 equal to a plus b. So another equation becomes a plus b is equal to 4. So you subtract these two equations, it becomes minus 3a equal to minus 3. So from here we get a equal to minus 3 upon minus 3, that is 1, and b is equal to, a plus b is 4, so b is equal to 4 minus 1, that is 3. So our remainder, this is our remainder, it becomes ax plus b, that is x plus 3. So the answer is option D. So this solves the question number 13.